Hi, I'm Jeff Peacock. I work down in the machine shop here as a lab manager. If you ever need me or have questions, you can get with me or Brian or Joe. We're always down here. Today we'll be doing lab 5. So far you should have learned a few things about the lathe. So far you've learned how to face parts, chamfer, parting, drilling, and reaming. I think those are the 5 things that you've learned already. The thing that we're going to learn today is how to make threads on the lathe. Alright? But before we get to how to make threads on the lathe, we got to learn what is a thread. Because all threads, there's infinite combinations of threads. Alright? Right here I have just a generic drawing of a generic thread. And I don't care what it is. It's just the general shape, all right? So I want to identify the anatomy of this thread. So if you would like to pause this video and draw this out, it would be very beneficial to you because these are terms that we're going to be using throughout the course, all right? And if you don't understand what these terms mean, you're going to be in trouble, all right? So the first thing we're going to talk about on this thread right here is the largest part of the diameter, all right, of the thread right here. It's called the major diameter. The major diameter. All right? So that's from the highest spot on one side to the highest spot on the other side. All right? We also have a minor diameter. The minor diameter is from the bottom of one thread to the bottom of the other thread on the other side. So it is the smallest part of the thread that's actually holding the thread together. Okay? Right here, we've got an angle. In typical standard machine screws, that angle is 60 degrees. I'm sorry if my handwriting's a little off, but it's 60 degrees. Alright, now we can create different geometries, but a standard bolt that you'll pick up at a hardware store will be a 60 degree. Alright? The dip from this feature right here, from one part of the thread to the next one over is called the pitch. Alright? So the pitch is a very, very, very important part of a thread. Other than the major diameter, it may be the next most important part. Alright? We'll learn why that's important later. So, pitch can either be from the top of one thread to the top of the next one, or the bottom of one thread to the bottom of the next one. It's all the same, it just moves up and down. But we have to really know the pitch. The other important thing is the very top of the thread. That is called a crest. The crest of the thread. It's not that important that you know what that's called, but I use that term throughout the semester. So if you hear that, that's what I'm referring to. The bottom of the thread is called the root. Alright, so we have a crest of the thread and the root of the thread. That is all you really need to know for terminology in the anatomy of the thread. All right, we're back, and now that we've learned about the anatomy of the thread, let's look at a way of identifying those. So your standard threads that you get from a hardware store that you pull out of your engine block out of your car are broken into two major categories: a unified and metric. Those are the ones we'll deal with most likely around the shop. There are other classifications, but they're kind of outliers, so we'll just leave those alone for today. So when we are identifying a unified thread, there's two components, all right? There's two numbers. This first one, in this example, is a quarter, 20, and then at the end there's a UNC. So if I was to ask somebody for a bolt of this size, I'd ask for a quarter, 20. All right? This first number, a quarter, is the major diameter of that bolt. All right? If you don't remember what that is, look down at your notes. You should have identified that on the drawing that I did. This next number is your TPI, which stands for threads per inch. So, within an inch of this thread, there's going to be 20 threads, full threads. All right? So, the two major things are the major diameter and the threads per inch. This last thing, UNC, just stands for unified course, which is just the classification that bolt is intolerance to. All right, so all of these threads have been classified, and they have to follow inside a certain box, if you will. All right, so UNC was unified course. All right, so this is just an example of what it may look like, right? So we can also change these two values right here to make a new thread. So down here I have written out a quarter, 28 UNF, which is another standard thread. All right. Again, this first quarter is the major diameter in inches. All right. So a quarter inch will be the major diameter. It will have 28 threads per inch, and this UNF is its class, all right, which stands for unified fine, all right. So again, it's going to have the same major diameter as this one, but it's going to have a lot more threads per inch, so it's a much finer thread, all right. So there's also a UNEF, which stands for unified extra fine. So in the quarter inch major diameter series, they don't really make one of those. So this is the unified. It's important to learn this, all right? Because what this will do is will save you a trip out to the hardware store when you go out. Because this quarter 20 and then this metric one here, which I'll get to in a second, are very, very, very similar. Just by picking them up and looking at them, if you don't know what you're looking at, you might think they're the same. You go to the store, you get a quarter 20, but it needed to be this metric size. Then it won't fit. So you're going back to the hardware store. So the two pieces of information we always need to know is the outside diameter, which you can measure with calipers. All right. Most of the time when you measure a thread, it will be slightly under the nominal value here. So we'd say it's a quarter inch, but it's always going to come in a little bit less than that. They do that so it's a little bit smaller than what it needs to be. So when you thread it into the nut, there's not as much resistance. All right. If they made it all the way to an exact quarter inch, it would the crest would dig into the root of the nut, and it would be very difficult to screw together. All right, so if we identify the outside diameter, that's the first big step, because then it will take a lot of the possibilities off the board. And then we just have to decide how many threads per inch. And then you can just take your little ruler and count out little, have an inch and then count out the threads. And you should either come pretty close to 20 or 28, right? If you have a quarter-inch thread. All right. So the other thread that we deal with a lot down here are metric threads. All right. Those are slightly different. They're made the same way, but they are identified differently. Right here we have an M6 by 1, and that's how we say it. M6 by 1. You just don't say 6-1 or 6 times 1. It's 6 by 1. All right. This first M just denotes that it is a metric. All right. If you're dealing with a print that's all in metric already, sometimes that M is not there. All right. It's just implied, since the whole drawing is in metric, that this is a metric drawing or a metric thread. This first number right here is your major diameter. Is your major diameter again. So obviously, since we're in metric, this is going to be in millimeters. All right, makes sense, right? And this X is very important. See how over here under unified we have a dash, right? That's usually a visual symbol that we're dealing with a unified thread. The X over here is the kind of the visual that tells us that we're dealing with metric. This 1 right here is not threads per inch, right? Because we've got a metric thread here. It would be very weird to measure things in inches if you're dealing with metric. So what this 1 right here is its pitch. So that means from one top of the thread to the next top of the top of the next thread is going to be 1 millimeter. All right. So when we look at these two, if I was to show you side by side, they would be very, very similar. You'd be probably hard pressed to tell the difference. But again, if we measured the outside diameter and then look at the thread per inch or the thread spacing, the pitch, that will help us identify this thread. So one thing about threads per inch, if you don't know the pitch of it, the pitch is equal to 1 over the threads per inch, right? That makes sense, right? Because we say there's 20 in an inch, so what's 1? It's going to be 1/20th, all right? So for this would be, your pitch is 1/20th of an inch, all right? So why is pitch important? Pitch is important because what we can do is, if you want to, later in your career, you'll be able to design your own threads, all right? And if you know the pitch, you're able to make accurate adjustments to that thread. So, like when we're out at the lathe and we turn the handle, right? And we're turning the handle and it's 100 thousandths per revolution. That means that the pitch of that thread that was ground was 100 thousandths. All right. So each turn of the dial is equal to a pitch. So that way, when we're making precision tools like the lathes and the mills that we'll get into, if we grind in these and make really nice threads, and we can really control the pitch, each full rotation of that thread will translate that thread. So if I had a precision ground quarter 20, if I turn that bolt one revolution, it would go in or out, depending on which way you're turning it, 1/20th of an inch. All right? For this, one full revolution, since it's a finer thread, will only be 1/28th of an inch. All right? So, pitch is important, especially if we're making precision threads to move translation stages or other equipment. All right? So, the example that we're going to use today on this, now that we've identified how to identify threads, let's look at item number 5. It's part number 5. It should be just a pin and it will have threads on it. So grab that out and take a look at it. It's got threads on it and it has a call out like this right here. It's a 1032 UNF. All right. So what does this 10 mean? Well, I said that was your major diameter, right? Your diameter at inches. But certainly we're not making a 10-inch diameter thread, are we? That wouldn't even fit on this little air engine. All right. So what happens is every threads below a quarter inch are given are assigned numbers. Okay, they're sometimes called wire sizes or just numbered threads. All right, so it's important to know how to know what the major diameter of this is. All right, I know it's going to be below a quarter inch. All right, so this scale goes from 0 to 12. All right, a number 0 is 60 thousandths. All right, and every time we add a number to that, we add 13 thousandths. All right, so a number 1 would have a major diameter of 0.73. All right, a number 2, 0.86. All right, we're not going to go through all of them because I'm sure you're good at math at this point enough to figure this out. All right, so here's a little equation that can help you figure out the major diameter. The major diameter is just equal to the number size it is times 0.13, or excuse me, 0.013 plus 60 thousandths. All right, so we've got this 1032. All right, so we just plug the 10 in here. 10 times 13 thousandths will give us 130 plus 60. Should give us a major diameter of 190 thousandths. All right, and so it goes up to 12 because once you go past 12, then you're into the quarter inch size. You're right there at quarter inch. So this is important to know right here. Have that in the back of your mind. So when you're dealing with smaller hardware, you'll know how to size these out. They actually do make a 00 or a double odd and 000 or triple odd, and those are just minus those. But those are very, 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 very small threads. You're talking like in like some precision Swiss watches, right? So small that they practically make no sense to even make them. Just remember, if you're trying to figure out the major diameter of your thread, it will be this. And also, if you're measuring the minor diameter of the thread, the major diameter of the thread, it's always going to be slightly under. So if we look at item number 5, The major diameter of the diameter of that pin is 0.1875, which is just underneath that. Again, that's to relieve it off so when it mates with the inside thread, it doesn't cause as much interference. All right, we're back here continuing Lathe 5 discussion. Before we get to the machines, we have to learn one more thing that we're going to do today. And that is called turning. Turning, all right? What turning is probably the most important thing of a lathe, right? All right? So far we've learned facing, and our facing cuts are across the face of the part, right? And those affect the overall length, right? We're just kind of shaving off a little on the front, all right? But what turning is when you can actually cut along the side of the part and actually shrink the diameter of that part down to whatever you desire, all right? So turning, between facing and turning are the two meat and potatoes of what a lathe does, all right? So let's go over this. I'm going to try to give you a step-by-step on how to make part number 10, or item number 10. It's the flywheel. Please pull that drawing out right now. I'm going to reference it quite a bit here. I don't really have enough room on my board here to give you every dimension, everything on this board, so you're going to have to follow along with me. The first thing is, if we look at the shape of this, we've noticed that we've got a few different features on this. So we have to start coming up with a strategy on how to manufacture this part, right? It's not just a simple cut it down the length and call it good, right? It's a little bit more complicated, all right? So what we can see here is on this, we've got a through hole, all right? We've got a through hole. So that's one feature. We also got this step right here, right? This part right here, let me use a pointer. This part right here, this little reduced portion is called a boss, a B-O-S-S, boss. If you hear me use that term, that's what I'm referring to. It's any feature that extends up and away from the main surface of the thing. Otherwise, if it was down into the surface, it would be called a pocket, but we're not going to be dealing with any pockets. So if you hear me say boss, this is what I'm talking about, is this portion right here. We also do have a little hole that goes, or a threaded hole that goes through the side. We're not going to worry about that today. That's a feature that can't be put on with the lathe, only because it's 90 degrees of the rotation of the part, so you can't do drilling to the side of the part when it's spinning. So that will be a later thing that we do at the mill. So for right now, well, let's not worry about that hole. All right. The only things we're going to worry about are this through hole and turning this box on our flywheel. All right. So this is the material that we started up with. We saw cut this. It's our 1-inch diameter, and it was cut at 5/8 length. All right. So it's just this little guy. So we got to make this little guy useful now. Okay. So, what I did is I drew this up here, all right? It's squiggly lines, I drew squiggly lines because right now we just have saw cut ends, all right? We have nothing that's nice and parallel or perpendicular to each other, all right? We've got to square this thing up before we can really get started, all right? So, the first thing we're going to do, we're going to put this piece in the chuck. And I just draw my chucks like this. All right. Just so you know that I'm grabbing on this side with my chuck, okay? So the very first step in making part number 10, your flywheel, so the first thing we're going to do should be the first step in every lathe process, just about. I can't think of a reason why you wouldn't do this every single time as your first step. The first thing we're going to do is face it, all right? That creates that nice smooth front from which we can then reference other geometry and dimensions off of. So we'll take our lathe tool and we'll just face enough off like this. So now we have a nice, smooth, clean edge. All right. So that's our first step. Again, that will almost always be your first step in every lathe process. All right. The next thing we're going to want to look at is we're going to want to look at making this hole here. All right. Brian talked to you about making holes. And if we look at the diameter, if we look at that front view of your drawing, you'll see that that center hole has a dimension of 0.1885 plus 1,000 minus nothing. All right, so we've got a one-way, one-sided tolerance or unilateral tolerance. All right. So when you see a hole dimensioned in 4 decimal places, what should your mind automatically think? Your mind should already jump to, I have to read this, right? Because Brian told you that the drills do not drill on a tight enough tolerance. So we're going to have to drill and ream this, all right? So our step number 2 for this, since we are going to make a hole, is we're going to have to just put that little center drill, all right? Again, we always want a center drill before we start drilling. So step 2 will be just taking your little center drill, making a little spot in there. That way your drill doesn't walk away, all right? So, step number 3. Now we're going to have to drill this. All right. Brian talked to you about how to decide which drill to use based on which ream you want to use. All right. So if you go back and you're not sure how I came up with these numbers, go back to the last video. Lab number 4, and review that content, because it's important to know how to choose the correct drill size for whichever reaming operation you want to do. Alright? I've already done all the math and all the calculations and everything. And I'm going to have to use a drill that's a number 16. It's a number 16 drill. We use the number 16 drill for making the face of the, not the flywheel, the crankshaft that you did in lab 4. We also use that same drill because our numbers, our reamer was almost identically the same size. All right. So our next operation will be to actually go ahead and ream this operation. Well, let me draw this. So we put that hole through it. All right. We want to obviously go all the way through the part. So step 4 will be ream. And for this, we'll want to use the .1885 ring. All right. Again, that's the small. That 1885 is the smallest my hole can get, right? And I want all the other tolerance. Like it's gonna, if it can do anything, it can make the hole slightly larger. That's why we want to stay on the bottom side of that tolerance zone. That way, if it makes the hole a little bit bigger, hopefully we're still in that same tolerance zone. So we're going to use the .1885 ring. All right. It's going to be important that you know which ream you're using. All right. Last lab was a very similar number. All right. So be careful with which ream you select. I've seen a lot of people ruin their parts because they choose the wrong ream. All right. So with this, we've got we're going to have a nice hole all the way through there. All right. From there, we've done everything we're going to want to do here. But you're probably wondering why are we not putting the boss on here? Well, the reason we're not putting the boss on here is because we still have an unfinished side right now. And if we start turning the boss right now, we're going to end up not having a whole lot of material to hold on to do the back side. So while this part is still the same size, right, except for just a little bit that's been taken off the front, it's roughly going to be the same size. All we're going to want to do is flip this thing over. That way we still have a big chunk to hold on to in our chuck. Alright, so I've cleaned up the drawing a bit, and what we've done is I've just redone this drawing just to show that we flipped this in the chuck. Alright, right now we have the nice clean face on the inside of the chuck, because that's where we're grabbing at. And now our saw cut side is now exposed for us. All right. So step 5 will be to flip the part. All right. I will put an asterisk here because it's important that when we flip this part, anytime you take a part out of a chuck and put it back in, it's never, ever, ever going to go back in the same exact way. You can get it to go back, but you're talking lots and lots and lots of very diligent work trying to get it exactly the way it was when you took it out. All right, a lot of measurements, a lot of equipment that you won't have access to. All right, so just trust me. If you take a part out and then just say, "Oops, I forgot to do something. I'm gonna put it right back in." Well, that thing's not gonna go in exactly. All right. So that being said, is we put a nice, highly controlled hole right through the center of this. So when I take that out of the chuck, flip it around, I have to ensure that this hole is still going very much on the center of rotation now that I reclamped it. All right. So what we'll do, I'll show you this when I give you the machine demonstration, that we'll use the reamer to replace this back in. All right. Because the last thing we want is this hole to be shooting at some sort of angle, all right? Because once we turn that boss on there and the through hole is at some sort of angle, when we run this flywheel, our flywheel will wobble and shake like this. It won't give you a very smooth motion because your center of rotation is out of whack from what you've actually turned your flywheel. So with that flipping apart, there's a little extra strategy to that. Just make a mental note that we're going to have to do something a little unique about that. All right. So after we flip that part and set it, the next thing we're going to want to do is face this part, or face this side. that says face it to length, okay? So not only do we want to just face this and clean it up, we're going to want to face this down enough till we get the correct dimension we're looking for, all right? So if we look at our drawing, what is that dimension? It says 0.50, all right, so a half an inch. So let's just assume that I've gone ahead and faced it, measured it, and kept facing until I get it down to the correct length, all right? So I've got it to the correct length, all right? Now, what we're going to want to do, this is where using our controls, our dials, it's going to become very important now, all right? Before we were just working in one direction, right? We were just taking pins and making them shorter, right? So, when I face this, I want to go straight down and set my Z to 0. What do I mean by setting my Z to 0? What I mean is we're using the top compound dial, right? And we're making it shorter, all right? And once we've got it down to the right length, we want to set the dial to 0. And what are we doing? We're creating this front face now becomes a datum from which we can start referencing, right? If we look at our drawing, all of our dimensions are coming off of this face, right? So we have to have and make that datum, right? So we've set that to 0. All right? Z0. That's the front of the face. All right? Our next step is going to be setting our X, okay? So far to this point, all we've done is just making things in the Z, all right, one axis, all right? Now we're going to start using our X-axis, our cross slide, okay? So now we've got to set our X. And the way we do that is we come out here, all right, we take our tool, and we just move it out here, just until we barely touch that outside diameter, all right? And when we just barely set that outside diameter, we stop, and then we can set our dial, our cross slide, to 0. All right? And what that does is that creates the outside diameter as another datum. All right? Now, we can take our tool and get it out of the way. So what have we done so far? So once we set our X and our 0, we've gotten 2 reference planes. And right here, we've created what is called an origin. All right? Origin. That origin is going to be our reference point for everything that we do going forward on this part. All right? So it doesn't matter if I take this tool and move it all the way around, as long as I come back to the 0, 0, my tool should be right at the corner of that part. That way we know where this part is located, and then we can start cutting on things. Yeah. All right? So, these two steps, 7 and 8, are very, very important parts. All right? If we don't set this origin right, your part will never come out correct. All right? So, step 9, we're going to start with turning the boss. All right? All right, step 9 will be turning the boss. Just give me a moment. I'm going to erase this and reconfigure this so it will be a little bit more clear because there's going to be quite a few steps as part of this step 9. All right, so we're back, and all I've done is I've just cleaned up the drawing. All I've really done is kind of zoomed into the part where, the portion of the material where we're machining. All right, so this is the part, which, here's the part overall. We're looking at, well, that didn't work. So, we're looking at this part right here, okay? Because we're going to be machining down here, all right? We're going to be running the lathe down here. We don't do anything back here, right? Because if we cut some material away because it's spinning, it's also cutting away from back here, right? So our tool's always down here. So I've just zoomed in this, and here it is. Hopefully that's clear for you. All right. This line right here, this dashed line, all that is our actual material that's still there. Where I've got the solid lines, that's what we're trying to achieve, okay? So, we've got to get rid of this whole chunk of material. So there's quite a few steps in that, all right? It's not really that difficult. It's just a lot of repetition, all right? So, we left off by setting our origin, which is down there, which is our X0 and our Z0, right? So, just as a recap, all right, we're going to have to really remember which way our axes are going, all right? So, this way is going to be your Z-axis, and into the part like this is going to be your X-axis, all right? Very, very, very important that you keep those two straight in your mind, all right? So, Z and X, all right? So, here's the big long list. All right, so we're at the point where we got to turn this boss. So what are the actual steps? All right, I have them all here in this box right here. All right, in this box, the very first step is retract to a positive Z value. All that means is we need to get out in front of the part, all right? Out in front of the part. So I don't care if you bring it way out over here, it doesn't make sense to, but you need to be out in front of this part. Alright? What we don't want to be is into the part, because our next move is going to be in the X, and if we're somewhere here, we're going to plow into the side of the part, which is never a good thing for your tool or your part. Alright? So first step, after we have set our origin, come out into the positive Z. Alright? So, I'm going to keep kind of drawing lines and following this, this tool around. Alright? So, there I am at step number 1. I moved out in front of the part, a positive Z value. Alright? Step number 2. Is move an X to a diameter of 100 thousandths. All right? So, remember X is going this way. So we're essentially going in this direction. All right? Again, we're out in front of the part. This dashed line is the front of the part. So step 2 will go in here. All right? So that causes some people confusion when I say X a diameter of 100 thousandths. So what that's doing is when we make a movement of 100 thousandths in the diameter, the lathes that we use all have our measurements. All of the dials are in diameter. All right. So every time I turn this, it's going to change the diameter of that part by this much. All right. So we touched off right here when we made our X0, and then we're moving into the part 100 thousandths on the diameter. So really that tool's just moving in 50 thousandths, but because it cuts on both sides, it affects the diameter down 100 thousandths. All right? So we're at 100 thousandths, and then now our next step will be to move into the part and start making our first cut. All right? So far we've just been out here in front of the part in the air. All right? So now we're going to go into the part. We have to look at our drawing. Our drawing says the length of this boss is 0.19. All right? So this 0.19, that tells us how far we have to enter the material. But I have written here that we only want to go in 180. And you're probably wondering, why is that? That doesn't seem to make sense. We should go to 190, right? That's the problem with doing that, going into 190, is that your tip will actually end up making a weird design on this shoulder. We want to be able to have a nice clean shoulder after all this is over with. So when we go in here, we're going to go in 100 and just Z into 180, all right? So that's step number 3, all right? So if I move that over there, what's going to happen is just by the shape of our tool, it's going to end up making, you'll see the more we do this, it's going to end up making kind of a Christmas tree shape along this thing, and we don't really want that to be part of our part. So that's why we stop short, and at the end we'll end up doing a nice clean finishing pass. Well, that's a little bit later in the steps. But so just make sure you only go to 180 or 185, somewhere in there. But you definitely want to stop short of the 190. All right? So that was step number 3. Step number 4 is just to retract straight back out in the Z. All right? Back out in the positive Z. All right? So we're going to just come back out to here, where we were just at, and now we're there. All right? So, this is where we start losing people. All right? They start to get confused. All right? They know they have just cut material off, but they have no idea what they just actually did, other than now there's more metal in the bottom of the lathe than there was when they started. All right? So, what you've just done, when we touched off, our piece right here is a 1-inch diameter. Right? 1-inch diameter, the whole piece. From here to here, 1 inch. And what we did is we just took 100 thousandths off of that diameter. So what should our diameter be, or roughly around? All right? It should be 900, right? 1 inch minus 100 thousandths. We should be somewhere in the neighborhood of 900 thousandths. All right? So, we have to know how big our boss needs to be. And if you look at your drawing, if you look at that front view, it says that diameter has to be 3/8, which is 0.375. All right? Right here. So, after that first cut, we're only at 900. So that tells me there's more that has to come off. All right. So this is where our next step is, which is just to repeat those last steps 2 to 4 until the boss is at 400. All right. So we left off right there. So we just got to keep repeating these steps. All right. All it's going to look like is your tool's going to come up here, come in, and stop, and then straight back out. That should be 800. 600. Or excuse me, 700. 600. 500. Straight back out. And then we should be right here. So how many steps was that total? Should be 6, right? Because if I'm taking 100 thousandths off each pass, that we started at 1 inch, need to get down to 400, that should be 6 passes, right? 1, 2, 3, 4, 5, 6, all right? So if we do, just keep repeating those steps, our tool should end up right here, all right? Tool should end up right there. All right? Actually, I take that back. It should be back retracted. All right? So all of this material is going to be gone. All right? So each one of these steps that's left, each time we make a pass, our back wall is going to have this kind of stair-step look to it. All right? Which we don't want to keep in the part, but it's there right now because we're about to set up for our final cleanup pass. All right. So what we want to do before we just go for this 375 is we want to stop the machine and measure the boss. We want to measure this boss because right now we're assuming we're at 400 thousandths. That's what we're assuming, all right? We just kind of roughed in our origin, but we want to be able to take calipers and measure that and make sure how close we are to that 400, all right? You may measure, it might be 405, it may be 410, it may be 390. It could be a little bit all over the place, depending on how well you set your origin. But it's not important how good you set your origin originally. What we're going to do is measure that boss, all right? You're going to measure that boss, and let's just say I just ended up right on 400. If I measured right at 400, how much more do I need to go in now to get to the 375? I need to go I should have to just turn my dial, since it reads in diameters, just another 25 thousandths, right? Because 400 minus 375 is 25 thousandths, all right? Sometimes this tricks people up because they think once they're here, they have to spin at 375 thousandths. And then their tool ends up like way up in here. Then they have no boss. They just wipe the whole thing out and wonder what they did. So this next movement should be a very small cut based on what we have been doing. All right? So this is what I have as step 6. Is measure that boss. If your dial is a little bit off of 0, I would reset to 0. All right, 7. Then we're going to move in to this final dimension of 375. Again, it should be somewhere around 25 thousandths, probably between 20 and 40 normally. All right. So it should be a very light cut. If your tool's way up here, that's not right. All right. It should just be a small little movement. All right. So So we move to here, that would be step 7. All right. So now we're ready to take our final pass. Step 8 is moving to 190. So I said we've had this jaggedy backside so far. That's because we were always stopping short of where we're needing to go to. But at this point, we're going to do one big cut, or it's going to be a light cut, but it's going to be one full cut and clean up this whole surface. All right. So number 8 step will take us to right here. All right. So step 8 will lead us right here. All right. We've gone to the full depth to that 190. And then step number 9 is we're going to retract in our X until you're clear of the part. All that means is we're going to go and just bring this tool all the way down, and it's going to end up cutting all these little steps all along the way. Like that. And then your tool's going to be ended up down here. Alright? Your tool's going to be ended up down there. And after all said and done, this will all be gone. And then you should have a nice 3.375 boss. Your shoulder should be nice and clean. This should be, it's going to be easy to measure this. This should be 0.31, right? Because the whole thing is a ½ inch. So this should be 0.31. So you should be able to have this nice flywheel. The last thing you have to do is just deburr it. Again, just take the file on the outside corners. Just kind of touch those real quick. You can take your chamfer mill and clean up those holes. All right. I believe that's all for turning in lap 5. I will show you how to thread and turn these parts at the mill, or excuse me, at the lathe here in just a moment. We're back at the shop here for lab number 5. I'm gonna show you how to make the threads right here. We are on item or part number 5. If you'll turn to that, I've got mine posted right back here. If you look at that, we talked about there being a 1032 thread. Obviously it's going to be on both sides, and if you look, there will be a ½ inch portion and a ¼ inch portion on this pin. Make sure you use the right pin. This one's an 1 1/4 inches. All right, don't use your 1 inch one. That's for your crank. All right, so we want to make sure you use the one that's 1 1/4 inches long. Okay, so here's our pin. I've got it chamfered on both edges. All right, what I'll do is I'll just put it in the vise so I don't drop it down in the machine. All right, here it is in the chuck. All right, I don't need this tool post for anything, so I'm just going to move this out of the way. Pull it all the way towards me and all the way down. Maybe not all the way down. There, it's out of my way. All right. There are several ways to make threads on a lathe, but the way we're going to do it today is by using a die. All right. This is a die. Actually, just the center part is considered the die. All this out here is considered the die handle. It's what is needed to hold on to the die. All right. It may be difficult to see, but inside here, there's little teeth. All right. These little teeth are going to be what cuts the thread onto our part. All right. If you look at a die, it will always tell you the size. All right. This one says number 10, 32 NF. and that is the size thread we're looking to put on here. So I've got the right die. So there's a front, there's a face like this, and there's the back side. All right, we always want to feed it in here. All right, if you look at the very center of this, there will be a little bit of a lead in, and the lead in is helpful for us to get the thread started. All right, so you choose the side that's got the lead in for the threads. All right, it will look kind of like a cone shape, and you'll see that it's not fully formed threads. All right, because it's actually bigger than the thread size. So that's the side we want to go on. All right, and to do this, all we're going to do is place it on there and start turning, and we'll turn it by hand. All right, and that will cut the threads on. So there's a few tricks and tips that will help do this to make this easier for you, because I've seen a lot of people have trouble with this. It's really easy, but it can also get a little tricky. All right, the first thing you want to do is take a look at your die. If you look down on each one of these things, you're gonna see the teeth. Just make sure that none of them are broken. All right, if they're broken, come to one of the instructors and we'll get you a new one. If the teeth look good, we're good from there. All right, the other thing we want to do to make our lives easier is put this headstock in a really low gear. All right, because as we're cutting these threads, it's going to apply force, and if you're in a high gear, it's going to make this spindle able to be turned really easily. So you're actually be turning the whole work piece and chuck. Okay, so I like to put this in a nice low gear. You see, if it's in a high gear, it can spin pretty freely. So if you put it in a low gear like this, it makes it pretty difficult to move. All right, so I can move it, but the cutting forces of what we're doing won't be able to rotate this chuck. Okay, so have it in the lowest gear, in the lowest setting. Check this, and the last thing is make sure that your workpiece is pretty tight in there. Okay, I see a lot of people, when they're cutting these on, they don't tighten this down enough, and it actually, like, the chuck may not be spinning, but the whole this little pin is spinning inside the chuck, and then we'll end up scarring up and marring up the outside. Remember, we use this drill rod. We use it for a very specific reason, because it's ground right to a perfect diameter. It's nice and round. All right, so we don't want to mar it up by it spinning inside the chuck. All right, that defeats the purpose of using this material. All right, so what we want to do is put these threads on straight along the center of rotation. If we somehow get this off-centered, it's only going to be able to cut threads for so much, and then it's going to break your die. All right, so we've got to align this and get this on here so that it's not crooked. All right, and the way we do that is we take our tailstock here. I'll loosen up the tailstock. All right, make sure it's out a little bit and it's secured in the taper. All right, and right here at the end of the drill chuck, you'll see that the fingers of the drill chuck are kind of sticking out. All right, what I want to do is rotate this enough so that I'll just pop it out. So, all right, I don't want these fingers sticking out of the body. Okay, I want to roll them back in so I have a nice smooth flat surface right there. All right, so they're back inside the body. We'll pull this quill out, stick that in there, and it's nice and tight. All right, so I've got the tailstock not locked down because I want it to be able to slide. All right, and what we're going to do, it's important that when we put this pin in,
We want to put it right in the dead center here, all right? I've seen people try to put it in these little holes. If you think of it looking kind of like a clover leaf, they want to put it out here on the clover leaf, all right? What we need to do is put it right in the center, okay? All these little holes on the around the side are just for a place for the chips to go, all right? So don't stick the material in there and start turning it like this. You won't be cutting anything. All right, so make sure you line it right up right there in the dead center. Okay, so what I'll do is I'll line it up. I'll place that die right on the center like that, and then I'm going to bring my tailstock up. All right, I'm going to bring my tailstock up enough so it pushes this die on straight down the shaft, all right? Because again, if I started like this, we'd end up with a broken die, all right? So by pushing this here, it's going to force that to go straight down that shaft as we're cutting, all right? When using a die, it's very, 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 very important that we use cutting rule, all right? So use it. It's there for a reason. All right, so I bathed it in cutting oil. All right, the first thing I'm going to do is do the 1/2 inch portion. All right, so as I'm turning this, I'm going to be cutting on threads, but how will I know if I'm at a 1/2 inch? Well, that goes back to knowing what our pitch is. What was our pitch on a 130, or excuse me, a 1032? The pitch on a 1032 is 1/32 of an inch. So how many full rotations will I need to get a 1/2 inch? I'd need 16, right? Because if I did 32 revolutions, full revolutions, that would be an inch. So I only need a 1/2 inch, so a half of 32 is 16. All right. So what we're going to do is count 16 full revolutions of this die, and that should give us our 1/2 inch. All right. So here's the key to getting this started. All right. What I'm going to do is I'm going to press and keep as much force on this tailstock to start this die going down. All right. I don't want to just kind of hold on to it. I don't want to just, you know, just touch it. I actually want to lean into it. I use my body weight, and what I do is I'll lean. I just put my palm here and I lean into it, and I'm just kind of leaning into this and putting pressure on that die. All right. If I don't do this, all I'm going to do is just cut one circle around the edge, because it's not going to want to grab into that material. So I'm putting most of my weight onto this, pushing it forward into the chuck, all right? And then now what I'll do is start turning. And I'm going to want to turn clockwise, right? Because it can go righty-tighty, lefty-loosey, but I'm trying to cut these on, so I need to go in this clockwise fashion as I'm looking at it, all right? So we can start cutting by going, there's 1, 2, 3, 4, 5. So usually by the time you're into about your 5th thread, you don't have to really push on this so much, all right? Because now this thread is going down the shaft as straight as possible. And now just the cutting of the die will actually keep it on track, all right? So at this point I can actually move it out of the way, but you can see my die is now on there. It's cut 5 threads, all right? So I just keep on going. There's 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So at this point you can see it's starting to come out on the other side of the die. That tells me I'm doing a good job of, as I'm turning it, it's actually going down the shaft, okay? So once we're at at 16 turns, I like to just go a little bit of beyond and then back and forth a couple of times. And what that's going to do is clean up the bottom of that thread, all right? Because in theory, there's a big long chip that's still connected to this. So if I go back and forth, that actually breaks that chip. And then all I have to do is spin it off. All right. And here it is. You can see all the chips collecting in here. That's fine. We can blow that away. All right. And there are your threads. All right. One thing that helps the threads. So when we cut these threads are going to kind of be sharp. All right. There's going to be burrs on the crest of these threads. All right. So what I like to do is I like to just turn on the spindle, and I'll take a little bit of this emery cloth. All it is like a very fine sandpaper on a cloth backing, all right? And all I'll do is I'll just kind of pinch it, all right? I'll just kind of pinch it. And that's just gonna knock the corners, the tops off of the crests, all right? It will clean up the very last thread and then now we should have some nice smooth threads. All right, loosen this up. Wipe it off for you. And then there, you'll have your threads, all right? If I was to measure that would be very close to a ½ inch worth of threads. Now all I'll have to do is put this back in and do the same on the other side, all right? Obviously a 1/4 inch length, so how many revolutions of the die would that be? It would be 8, right? Because 1/4 of 32 is 8. So I would do 8 full revolutions. It's the same thing, but instead of going 16 turns, I'm doing 8, and then we'll put that portion on that end of the shaft. So once you do that, that part will be done. So that will be one of the parts that you have to do for lab 5. All right, we're continuing lab number 5, and we're going to be turning the flywheel now. And so this is the part that we should have had cut from earlier in the semester. It's just a 1 inch diameter with a 5/8 length. And so we're going to turn this into our flywheel. So the first thing I'm going to do is I'm going to put this in the chuck. All right, I don't have to leave a whole lot out because I'm just cutting a little bit off of the face of this, and I'm going to end up drilling it on this face, so I don't need a whole lot of this material sticking out. So I've got it in there nice and tight. And then we're going to take our right-handed turning tool that we ground earlier in the semester and put it in the tool post. Okay, I've already made my gear selection, my speed selection. I did that by 4 times the cutting speed. And the cutting speed for mild steel is 100, so 4 times 100 divided by the diameter, which is 1 inch. All right, so 400 divided by 1 is 400. So I've selected my closest speed to that, and now we'll start. I've already preset my tool height and my tool position so that it will cut correctly. So the first thing, step number one, was to face this part. And all I'll do is just move in with my course wheel right here that moves the whole carriage, and I'll just barely make contact, and then bring it out, and then I'll move it in maybe about 10 thousandths or so. Apply some cutting oil, and just make a nice clean cut across the face. Now that didn't seem to clean up everything, so I'll just move in like another 5 to 10 thousandths and try that again. There we go. Now I can see good chips coming off, and now I know I'll have a good face on the front of this part. All right. I'll inspect it, and sure enough, it's all cleaned off the front. All right, so step number two is going to be the center drill, and we're going to use the tailstock for that. So here's my number 2 center drill right here. You can see that. I'm just going to put this into my tailstock in the drill chuck. All right, got it in there nice and tight. Make sure everything's out of the way. All right, what I'm going to want to do is take the big handle and lock this down because I don't want my tailstock sliding up and down the ways. So I'll tighten that up. All right. And now I'll just go in just a little bit. And so there's the center drill. Unlock this and bring it back out of the way, because now I'm going to need to drill with the number 16 drill. Alright, so that's in there nice and tight. I have to change my speed, right? Because the maximum size diameter that I'm cutting is not the 1 inch anymore. The outside diameter of this, it's going to be the diameter of here, of the drill. Alright, so we'll change our speed. We'll actually need to speed it up a little bit. Alright, so put some cutting oil on the drill. Get my drill up here close. Alright, this feature goes all the way through the part. So once I lock this down and turn it on, I'm going to drill all the way through the part. It will be very apparent when you get all the way through the part because it won't feel like it's cutting anything anymore. Alright. Alright, so I drilled that out. And then the next thing we're going to do, step 4 will be to ream with the .1885 reamer, right? Based on our tolerance, we wanted to choose this reamer. And it should say it right here. You guys won't be able to see it on camera. But for me, I can see that it says 1885. That's the reamer we want. So it's going to be a little bit larger than the pin that's going to go through there on final assembly. And now we'll have to slow our speed back down for a reaming operation. There we go. All right. I'll just get this in the ballpark here and then lock down my tailstock. We'll apply some cutting oil, and when the best practice for when you're reaming is to go nice and smooth in, all right? Any sort of jerky motion that you enter the part with doesn't give you a great reamed hole, all right? So you want to keep a nice slow and steady feed in there. You don't want to be fast because then the reamer will not have time to find the center of the hole. All right, so I'll go nice and smooth in and pretty quick out. When I retract out or when I pull my tool out, I want to go a little bit. I don't want to stay in that hole and just dance around, because then that reamer will start bouncing around that hole and actually making it larger than what we want to. So nice and smooth in, let it cut. Make sure we go all the way through the part, which it is, and I come out nice and quick. All right, I don't want to spend too much time in that hole when it's not cutting, because again, it will start bouncing off the sides of that hole and start wallowing out your hole or making it a funny shape. All right. So I will wipe this reamer off, and normally we always want to take the tools out of the tool chuck when we're done using them, because of safety concerns of cutting yourself on drills and whatever else you put in here. But we're going to need this setup for when we flip the part over. But before I flip the part over, I want to just quick deburr it. I'll deburr the outside edge, and I'll take my chamfer mill and chamfer the hole that I've created through the center. Alright, so I just deburred the edge, then I'll just take my my chamfer mill, and I'll just put it in that hole and just press slightly. There should just be a little chip that comes off of it, and that's just enough to break that edge. One way to check to see if we use the right reamer and that the hole is the right size, we don't have a go, no-go gauge for this, but this hole is supposed to accept our flywheel. All right, we'll actually mount on the back of our crank. All right, and our crank's got a 3/16 pin, which also your number 2 is ground to 3/16. All right, so as a quick check, if that number 2 center drill goes in, we use the right reamer. If it doesn't go in, you use the wrong size reamer. All right, it should just barely slip in there, nice and tight. All right, so we use the correct reamer. We've got everything done on this face that we want to do. All right, so now we're going to go to flipping it around. Remember, anytime you take something out of the chuck, it's never going to go back in the same way it came out. All right, so when we turn this around, what we're going to want to do is mount it on this reamer. All right, because that is right at the center. That's the hole that we just reamed, and if I mount it on there, it's going to keep this hole right in line with the center of rotation. Again, I don't want that hole that we just reamed to be off axis in any way, because that's just going to make your flywheel tumble and fumble about. All right, and that's not what we want. So I'll put it here on this reamer and then slide it back. Let me wipe my chuck out a little bit here, so we're not gripping on chips. All right. I'll just bring this in like so. All right. Since we have to do quite a bit of work on this face, we got to get it down to size and turn that boss on. I don't want to put it in the chuck so far that as I'm cutting, my tool runs into the chuck jaws. All right, that's not good. All right, so I just clamp on just a little bit here on this back side, so maybe maybe a third or so of the part, maybe a little less than a third. All right, so once I've got it there, now I can clamp down on it. All right, and then we'll just move this reamer out of the way. All right, since I'm done using this reamer, I want to take it out. All right, so now this hole that we've reamed, we actually came from that side, we flipped it, now it's nice and in line with our center of rotation. All right, I'm not going to need the tailstock anymore, so I'll slide that out of the way. All right, so step number 5 was to flip the part using the reamer. All right, now step number 6 is going to be facing this part and getting it down to our 1/2 inch length. All right, so the first thing I have to do is at least face it once, and then we'll measure it. So if we look right here on this dial, down here on our compound slide, I've just faced that off. And what I'm going to do is I'm just going to set this to 0. All right, for the time being, it's just going to be a temporary 0. It will help us figure out how much further we need to go to get this down to a 1/2 inch. So now I have two parallel sides. The back side and this side are now parallel to each other, and so I can measure this with my calipers. Right now, these calipers are measuring 0.583. It has to go down to 0.5, so that tells me I've got 83 thousandths I have to take off of this. All right, so 83 thousandths. So what I'll do is I'll probably do this in 30 thousandths passes. All right, so I'll move 30 thousandths. All right, this is no different than when we were trimming our pins down the length. There's 30 thousandths off. I'll go another 30 thousandths. All right, so that was a total of 60. All right, I'll go 20 thousandths and I'll end up, this will be will put me at 80 thousandths off. All right, and I had so that I'm at a total of 80 thousandths and I had to go 83. So I'll just move in 3 thousandths and that should give me a nice really clean surface. All right. Your final pass should always be a nice, light little cut. moved anything. I have not moved the cross slide at all. All right, I'm still sitting at 83. I want to just verify that I cut this down correctly. You should be right at a ½ inch. All right, well, I'm at 498.498, but we have a 10 thou tolerance, so I'm well within tolerance. All right, so all I've done is face and come back out, and then now I want to set the 0 here on my cross slide, or excuse me, on my compound slide. All right, so now we're at 0, and my tool, if I were to move it in, is right on the face of that part. So I've set this front face of my part and 0, and that's now a datum. All right, so that was step number 6. Now we need to go to step number 7, which is to set our, step number 8, which is to set our X. All right, and to do that, we're just gonna, remember, we're just gonna touch the outside diameter of here, and then we'll change our cross slide dial. All right, so I'll just move this in. The Z just a little bit so I can touch the outside, and I'm just going to go real light and slow. All right, it just barely made contact. All right, just barely made contact. I'm not sure if you can see on camera or not, but we just barely made contact and just barely made chips. All right, and then we retract it out into Z. All right. So down here on my cross slide, I want to set this to 0. All right, and that's going to represent the outside diameter is at 0. All right, so that's at 0, and if I move this back to the 0 right here, it's going to be hard for you to see, but the tip of this tool is right at the tip of the part, right on the edge. All right, where the outside diameter and the face of that part come together, that's where the tip of my tool is. All right, so now we're all set up and we've established a good origin. All right, so now we're going to go to step number 9, which is turning the boss. All right, so first part of turning the boss is get out here in the positive Z. All right, just out somewhere out in front of the part. All right, now if you look down here at my cross slide dial, I'm sitting at 0 still, so I'm at on the outside diameter of the part. I want to go in 100 thousandths on the diameter. And you may or may not be able to see it, but you can see that this machine reads in diameter. All right, so each tick mark here is 2 thousandths off the diameter. Okay, so we want 100 thousandths off the diameter on this first pass. So I'm going to move in the X to 100 thousandths. All right, I will turn on my machine. Use some cutting oil, and then now I'm going to go into the part 180 thousandths. So you should be able to see here on my dial me going in 100 thousandths. All right. Right now I'm just trying to get back to my 0. Right there is the face of the part at 0. Now I'm going to drive it in to 180. There's 50 thousandths, 100 thousandths, 130, 160, and 180, and I'm just going to come right back out. All right. And you'll probably have a buildup of chips like this. So if you need to, stop your machine and clear those chips out. All right? And so that's the process we're going to repeat until our boss is somewhere right around 400 thousandths, which is a total of 6 passes. So that was our first pass. So let me just repeat this a few more times. All right, my tool is out in front of the part, and then I'm going to go in another 100 thousandths, which brings us back to a 0. All right, there's the 0, that's the front of my part. I'm going to go in 180. There's 100. And 80. Right back out in front of the part. I'm going to move in another 100 thousandths. Cut to a Z depth of 180 and back out. I'm moving in another 100 thousandths. Straight back out. I'm going to move in another 100 thousandths. This will be my 5th time doing it. You can see those chips curling. That's a pretty good chip and how they should look when they come off the tool. All right, there's 180. Out in front of the part. So these are good chips. This is what you're looking for right here when you're cutting. If it's all just small little crumbles, like little crumbs, then you're probably going too slow. And when you go too slow, you build up too much heat in your tool. We want to keep the heat as we're cutting into the chip. All right. So if you're cutting too fast, this metal will start turning black or purple, and you're heating it up a lot. All right. If they're turning black on you, you may need to slow down. If they're small and crumbly, you need to speed up. All right. It's all a feel thing. You'll get used to it. All right. So I've done 5 passes. I'll need to do one last pass. All right, I'm out in front of the part. I'm moving another 100 thousandths. Going to the Z depth of 180. All right, and straight back out. All right, so I'm going to move this back a little bit. My tool a little out of the way, because now what I should be is somewhere right around 400 thousandths on the diameter of this boss. All right. So I will measure that. I may have to be in the way of you seeing. All right. I'm at 396. 396. All right. So I was assuming I'd be somewhere around 400, but I'm really at 396. So if we look at our drawing, that boss is supposed to have a diameter of 375. Right now I'm at 396. So that means I have to take 21 thousandths off the dial, or off the diameter. Okay? So if you look down here at my dial, on my cross slide, I'm just going to make an adjustment to 21 thousandths. Now each tick mark is 2 thousandths, so I'm going to have to split these All right. I'm gonna have to be in the little of the middle. All right, so there was 20, and I went just half a tick mark before the next one, which would be 22 thousandths. All right, so see, I just barely moved it. All right. So now that I'm at the correct diameter that I need to be, I'm gonna want to take this tool. This is my finishing pass, so it's very important that you know what you're doing before you make this pass. Because the last thing you want to do is go in to the Z and then just leave the tool there while you try to figure out your next step. All right, if you just leave the tool in there while it's spinning, you're just going to generate heat. And it's going to break down your tool, and it's going to ruin your part a little bit, all right? So I know that I'm going to go in 190 now and then straight back out in the X. All right? I'm where I need to be on my X right now, so let's go and do that final pass. It's going to be hard for you to see, but this face of, here, let me get a pointer. All right, this face right here of our flywheel is all jaggedy right now. So when we go in 190, we're going to cut underneath that jaggedy surface, and as we pull it out straight, it's going to smooth that surface right back out. All right. So again, I'm where I need to be in my X. Put some cutting oil on, and now I'm going to take my Z into 190. There's 140, 170, 180, and we're going to drive it all the way to 190, and then straight back out. You can see it cutting that shoulder and cleaning it up. So that was the last two steps of turning that boss. All right. All right, I'll wipe it down a little bit. And before I take this out, I'm going to reiterate that before you take this out, this is the time to make the measurements, all right? Because we still have all of our origins set. We can always go back to 0, 0. Even though we don't have the corner of the part anymore, if we go to 0, 0, that's still our origin. We can make fine adjustments if we need to. If we take it out and everything else, we'll never have that origin won't match up, okay? So before you take it off the machine, we want to verify all of our dimensions, all right? So I should have a diameter of 375 here. And I'm at 376, which is fine because we got a 5 thou tolerance on either side. So my boss is the correct size. Now I just want to measure my shoulder. We'll just measure the big part of the flywheel, which, if we look at our print, should be 0.31 or 310 thousandths. All right, because our part's half inch. We went in 190. That should give us 310. All right, and wouldn't you look at there? I'm at 311. All right, so I had a 10 thou tolerance on that, so I'm good there. All right, so everything right now is measuring correctly. So since everything's measuring correctly, the last step will just be to deburr this and clean everything up. So let me get my tool out of the way here. All right, the things I'm going to deburr are this shoulder right here, the big shoulder, or the big part right here. We're going to measure this edge on the boss, and we're also going to take our our chamfer tool and put it in here, and we'll clean up the burrs on the inside of that hole. All right, so we can chamfer that back a little bit. All right. All right, so that's it for that. Just put that in there just to break the edge. All right, that is our completed part. Let's pull it out. Let's see how she looks. All right. So there's our finished part. All right. You can see that we've reamed this hole. We've turned this boss on there to the correct dimension. That's what the backside is. The better you get at this, the better your surface finish will look. But that's your finished part. So that will also be due for lab number 5. So you'll have the threaded part and you'll have this flywheel to make for lab number 5. And that concludes lab number 5.